was never even here.
We're now being recorded, so I think they got your cloud comment. All right, so we're looking at a couple different problems from 5 to, we can do any of these. There's a simple linear one, another simple linear one. Let's go back to this one. Number 12, this might actually be from homework, I'm not for sure. I don't remember where number 12 came from, okay? And then we're gonna look at this review, and then we're gonna look at properties of integrals, properties of the definite integral, which is, you really have to make that one as easy as it is. It's not a complicated one, but then we're gonna watch a video and talk about average of an integral, okay? So, real quick, we have this one. Let's go ahead and set it up into our integral. We know we start off with, and you know the question is coming, so some of you might be looking this up in notes because you know I'm gonna ask the same question. So we start off with the integral symbol, and what does that integral symbol mean? It means a couple things.
It's the limit as h approaches.
Don't tell me what it stands for. Tell me what it means. Tell me what it does. It tells you to do.
Oh.
All of that mess you just started to read, what does that tell us? What are we doing?
Adding up all of the points between the two.
Not points. We're adding up all the
Values, numbers.
Sums. Or
that's adding up. But what are they? They're all a bunch of what shape?
Oh, the rectangles.
We're adding up all the rectangles. Okay, keep going.
Adding up all the rectangles under or above the graph, on the y or x-axis. We're just adding all of them up, and they're infinitely small, and there's an infinite number of them.
Very good. So you're adding up an infinite number of rectangles that have a base of 0. That have a base that's approaching 0. So that's what we're actually doing. So we're gonna have a whole bunch of, so then that's what this symbol means. And then we know 0 to 3 is my lower limit to my upper limit. Okay. And then we're gonna put in my height of the rectangle times the width of the rectangle. So what's the height of the rectangle?
2. Or is it 2?
0. No.
What'd you say?
That's 2.
Not 2. What's the height of my rectangle?
3.
Say it again.
Is it 3?
It's not. So
That's
if I
the
take
formula, right?
if I take this function and graph it, negative x over 2, so I don't know, something like this, what's the distance from here to there? That's the height of the rectangle, right? So it's the
equation.
It's the function. So I'm gonna make this negative 1/2 x squared. Okay, because we have negative 1 over 2 x squared.
CHS staff, would you please at this point release students who are participating in the Black History Month program rehearsal to the auditorium? There should be a list coming out by email in just a moment, but if they say they're on that list, then let them know. Thank you.
So that's the height of the rectangle. So we're gonna take the height of that rectangle times its width. What's its width?
0.
What'd you say?
0.
It's going towards 0. It's heading towards 0. It's approaching 0. What'd you say?
2.
Not 2.
1 over infinity.
What was the question?
This is think about the makeup of our equation. This is telling me we're adding up a bunch of rectangles from 0 to 3 that has a height of 1/2 x squared and has a width that's approaching 0. So what do I put in here for my width?
dx.
Oh, dx.
Dx. So not only do we look at that and say, what in the world, how do we solve that? We know what everything stands for. We know what the limits stand for. We know what the integral symbol stands for, the height and the width. Okay.
So negative x squared over 2 is literally just equal to negative 1/2 x squared. Well, negative 1/2 x squared. Like you've got.
Yes, because that's just negative 1. So negative 1 over 2 x times x squared.
Okay, excellent. Yeah. I just
Okay.
wanted to make sure I had that
So let's go ahead and solve it. It's a parabola, upside down it looks like to me. So we really can't find the area using formulas like rectangles or circles. So let's do the antiderivative. So this is going to be equal to, what's the first step in finding the antiderivative? Remember we did the steps forwards and backwards. What's the first step?
It's with the coefficients, right?
No.
Oh, no.
Take this one times, or divided by that.
Nope.
You add to the exponent.
We add to the exponent. First thing you do is add to the exponent. X to the third, you add 1 to the exponent. That's always the first thing you do. Now you're going to divide. Now I'm going to take the 3 and divide it out front. So it becomes basically, I just multiply the denominator by 3. Negative 1/6. You divide by 3, which is the same as multiply the denominator. Okay. All right, so we have negative 1/2 x squared equal dx. That antiderivative is negative 1/6. And if you think about it, to take the derivative, you bring the exponent up front, just gives you negative 1/2 x squared. So kind of check it forwards and backwards. Then I draw this really ugly line according to Susan. She doesn't like that line there. And then 0 to 3, which I don't know why. I think it's kind of a nice notation, but
I think it's a beautiful.
I think it's a beautiful notation. Okay, so then after we draw the line, because the line means, okay, now we're going to evaluate. By the way, you don't know this yet, but we're evaluating using the fundamental theorem of calculus. Okay, and the fundamental theorem of calculus will tell us what minus what. Give me the location.
The largest, or like the furthest right minus the furthest left.
Okay, so we're gonna go, actually it's gonna be right minus left, yes. But this isn't right or left, this is on the y-axis.
Up or down?
Top minus bottom. So top minus bottom. Remember top minus bottom, left minus right? Okay, so I'm gonna put in the top first. So I have negative 1/6 x, I'm sorry, not x because I know what x is. X is 3. So negative 1/6 times 3 to the third power minus negative 1/6 times 0 to the third power. We do the top minus the bottom. Okay?
Oh, so then it's just 0 minus.
Now, what is 3 to the third?
9. It's not 9. It's.
Get out.
I'm sorry. Okay.
What is
27.
27. So 27 divided by 6 gives me, we also, right now, I'll just put negative 27 over 6 minus, all right, someone else besides Evan, and you better not get this wrong. What is 0 cubed?
0.
Times negative 1/6?
0.
0, so this is just gonna be 0 over here. All right, so I have negative 26, which reduces to negative. Negative
9/2.
Reduces to negative 9/2. And I don't need to worry about the minus 0, so my answer is negative 9/2.
That took me a minute.
All right, and that's basically 5.2. Any questions on any of that? I'm gonna do another example probably on Friday, and we're gonna go through and ask you all the same questions, because you have to understand. What does that symbol right, hang on, wait a second, pause for effect. What does that symbol right there mean?
You're adding up all.
So.
You're adding up all the squares.
All the
with a
rectangles.
width or all the rectangles with a width of 0 under the graph in the range.
From the graph to the
X.
x-axis, I'm adding up all those zeros. Very good. And then the 3 and the 0 mean what?
The like
That's the
range.
actual domain.
That's the limits of the domain. Very good. And then this right here is the
Height.
height, and this right here is the
Width.
width of every single one of those little rectangles. Okay, very
Let me
good.
quickly illustrate that.
All right, so let's go to then. If you want to look at your page, your book is page 285. You might just jot that down. It has all of these properties spelled out for you. Not too complicated, so let's go through each one.
Is this into 5.3 now?
This is 5.3, yes.
Alright, let me make sure I illustrate that.
And it's called properties of integrals, the property of the indefinite integral. Now, the very first property, I don't care which one you write down. You can write down the notation, you can write down the definition here, you can write down both. I'm not gonna spend a lot of time going through the definitions of them, but I'll just hopefully try to give you some time to write. But if you look at the first two, on this one we have a to b, f of x, and on this one I have b to a. So really all you have to know then is that if I reverse the limits, it changes the sign.
What do you mean reverse the limits?
If I go from A to B, but I switch it and I go from B to A.
Mm-hmm. What sign is gonna change it? Oh, it makes it negative instead of
Changes
positive.
negative, and
Okay.
notice where the negative is, it's out front. Just
Yeah.
changes the sign of your answer. So, if I'm asking for, I want this on board so people can see it. So if I'm asking for, let's say we have a function, and I'm going from A to B. And I say, okay, find the integral from A to B of f of x dx, and I tell you the answer is 7. Okay? That means it means, if you think about it, I'm putting in the rectangles from A to B, correct? Okay. If I reverse the directions, if I say the integral is going from B to A of f of x dx,
Oh, well, yeah, that makes sense.
that means I'm going to go from B to A and filling them in backwards. That means it's going to be a negative. It's going to be the negative of the A to B. It's just going to change the sign. Actually, I know what the answer is at 7, so I can just make it negative 7. That's what I was not thinking. So it's just a negative 7.
Why would it be negative?
Because it's basically you're going the different direction. I'm filling in from A to B, so I'm filling up in a positive direction. B to A, I'm filling up in a negative direction.
So you could
So
use
it's just
this like,
notation on like what direction you're going.
Correct. Now, that also will affect you underneath, because if it's underneath, it's negative. If I go from B to A, that's going to be a negative, negative, so it'll be positive. If I go from left to right, it's just going to be negative. So it kind of affects that a little bit as well. But really, the idea then is just simply, if I reverse my limits, it just changes the sign of my answer. Okay, we good? We good? No, number 2. If I go from A to A, in other words, if the limits are the same, that's been there for like a week, I think. You may not want to eat that.
Yeah, I'm gonna
Okay.
go away.
So if I go from A to A, it means it's the exact same limit. If I'm gonna go from 2 to 2, or from 7 to 7. Well, I'm not going left to right at all. Okay? I'm taking the area of one of those rectangles that has 0 width. So the answer is obviously going to be 0. If the limits are equal, the answer is just simply 0. There is no area underneath that point.
does it say A over A?
A to A, yep.
A to A, gotcha.
Yep. If the limits are the same, now that could be any value, positive, negative, rational, irrational, doesn't matter. If these limits are the same, your answer is just going to be 0. And that just kind of makes sense because I'm at, x equals 4, I'm not going left to right, so I'm not making anything.
You threw away my.
Okay, you good? You good?
Yep.
Evan, you good?
Yep.
Number 3.
I'm not good, I'm not good.
Number 3. Probably one of the more important ones. If I have a constant here, if I have a k right here, like it's 2 or 7 or 13 or whatever, I am allowed to take that k and move it out front. And it won't change my final answer. So constant multiples can be moved outside. I'm going to give you an example of that here in just a moment. But I hope it works out, because I just thought of it. We're going to use this a lot when we get to chapter 7 and we're doing solids of revolution. Okay, we're going to have pi inside this thing on every equation, so we'll be able to move pi to the front and just not deal with it until the end. That'll help us out a lot. Okay, we good? All right, here's our example. Let's go back to this problem right here. Okay, does this one have a constant in front?
No.
Sure it does. Has constant -1/2. That's my constant variable.
You rat.
So let's take this, let's put this to the test. Let's see if this works. Let's take that -1/2 and put it out front. Times the integral from 0 to 3. And then I'm left with just x squared dx. So all I've done is I've taken that negative 1/2,
Okay.
I've taken that negative 1/2 and I moved it out to the front. Okay? Now, what does that do for us? By taking a constant, in this case, a negative 1/2, out front, really, what does it do to help us? Does it do anything to help us out?
Not really.
Okay, not really?
Not really, but it makes it easier.
It makes the antiderivative easier, is what it's doing. Cause I can take the antiderivative of x squared, we should know that pretty easily. So, what I'm gonna have then is negative 1/2 times, now the antiderivative of x squared is,
X cubed.
1/2, well, 1/3 x cubed.
1/3 x cubed. Evaluated from 0 to 3. So that's gonna be equal to negative 1/2. I'm gonna have 1/3 times 3 cubed minus 1/3 times 0 cubed. Do the same thing, top minus bottom. Exact same walkthrough. The only thing difference is on this one, this constant I'm gonna keep out front. What is 3 cubed?
27.
Divided by 3?
9.
9. And we know this is all gonna become 0, so that's just gonna be 9. And then negative 1/2 times 9 is negative 9/2. So by taking that constant out front, all it's really doing is helping us make a simpler computation. It's taking out that negative 1/2 issue. That's all it's doing. Okay? All right, so number 1, if I reverse the signs, if I switch the limits A and B to B and A, what does that do to the whole answer?
Negative.
Makes it a negative or makes it a positive, changes its sign. If the limits are the same, A and A, what does that equal?
0.
Doesn't matter what the function is, doesn't matter anything else, doesn't matter what the numbers are, it's always gonna be 0. Okay? And then if I have a constant, I can simply bring the constant out front. Number 4. Oh, hang on.
There is no 4
There is a
anymore.
4, here we go. Integrals can be added and can be subtracted. Okay, this one's a little bit longer,
Yeah, just a little.
but I'm taking the integral from A to B of 2 functions, f of x and g of x. Well, that's the same thing as if I take the integral of f of x and the integral of g of x and add those 2 things together. It's going to give me the same exact conclusion. I think I have an example of this. Yep, we have an example. I think I have an example. And once again, you can look at page 285 if you need a little bit more on this one. Now, do notice one thing on this one. What do you notice about all the limits?
They're the same.
They're all the same. If I'm doing f and g from A to B, then it has to be f of x from A to B and g from A to B. Okay? Number 5, integrals can be added or subtracted. Do we ever have that one? What's that one say? Integrals can be added or subtracted. Intervals, not just integrals, but intervals can be added or subtracted. So this one, if I have the same function, f of x,
Wait, what was the difference in wording?
this is integrals, so I'm taking f of x, 2 different functions. This one, if I just have intervals, like from A to B and B to C, I can simply add that and have A to C. It's like saying this one here is finding this area between A and B, right? And then from B to C, I'm finding this area here from B to C. Well, that's just the same thing as from A to C. We've already kind of done that one. We've already done this this particular property. Okay, when you're done writing, I'll show you the one we did a couple days ago and did this property actually. Remember that example in class? And we had one, and we had one above and we had one below, and we did them separately and then just combined them, whether it be total area or complete integral or whatever we wanted. That's that principle. All right, now, I think the next slide, okay, don't write all this slide down. If you want a copy of it, I can print it and send it to you, or if you want to take a picture of it, that's fine. It's just a lot of writing, and I don't want you to take the time to write it all down, okay? But I do want you to see it. All right, here's our problem. And I apologize for the blurriness of it. I just didn't want to retype it all, okay? Suppose that f and h are continuous functions and that. So the first one we know, on the function f of x, from 1 to 9, that's going to equal -1. We know that. From 1 to 9, f of x is going to equal -1. From 7 to 9, f of x is going to equal 5. Okay? And then h of x from 7 to 9 is going to equal 4. Okay? So there's my three integrals. Okay? So in part A it says, find -2 f of x. Well, what can I do with that -2?
Oh, move it out, cause it's a constant.
Move it out front. So it simply equals -2 times the integral from 1 to 9 of f of x dx. So that's going to be -2 times, what is the integral from 1 to 9 of f of x dx?
-1.
So the answer is simply 2. So we'll take -1, the answer times -2.
Let me get that, cause it's creative, I like that.
You might want to wait until we do the whole 6 of them.
Fine.
I know, it's terrible. Okay, what about b? I have the integral from 7 to 9, okay? And I have f of x plus h of x. What would the answer be?
9.
How'd you get that?
Because you add the last
Sure, it's simply the integral of f of x from 7 to 9 plus the integral of h of x from 7 to 9. So it's simply 5 plus 4. That's not too complicated, right? It doesn't get much more complicated than that. Okay?
Okay.
You can say, yay, praise God. Okay? But there's not a lot of these questions on the test either. So. Part C. The integral from 7 to 9 of 2f of x minus 3h of x. Okay? So how would I find that one?
We can still pull those constants out, right?
You can. So all it's asking for really is, what is 2 times the integral of f of x from 7 to 9?
10.
7 to 9 is 5 for f of x,
So 2 times that is 10.
Yeah.
What is 3h of x?
12.
Do you see that?
Mhm.
So the answer is going to be -2. What about D?
Mm.
1.
Agree or disagree?
Agree.
Why do you agree?
It's just, I'm looking at it.
The limits have just switched from 1 to 9 to 9 to 1, so you simply change the answer, the sign of the answer. So it's positive 1.
If that value was -2 instead of -1, would the alternate be 1 over 2?
Nope. Change the sign.
Okay, so that's all we have to do in this case.
So I got it. If it was -2, the answer would be 2. Okay, so I'm gonna move this up a little bit. Well, let's see if I can get the whole thing on here. Here we go. Try E. This one is a little more difficult, see if you can figure it out. From 1 to 7 of f of x.
Oh, what?
-6.
Oh, 4?
Okay, so I had -6, I had 4. You have an answer yet?
I feel like 4.
You think 4?
Yeah.
Okay. What's the answer from 1 to 9?
-1.
So the whole area is -1, right? What's the distance from, what's the area from 7 to 9?
5.
5. So if I have the whole thing, how do I get this side here?
You subtract the.
I would take the entire area
Oh, that would be
minus
-6.
this area, leaves me with what's left. So So I have -1 minus 5, the answer is -6. And sometimes it helps to sketch a little diagram of it. Because notice, if the area is -1, where should this be drawn? Most of it should be underneath the, but it doesn't really matter as long as you're dealing with numbers. Okay? But the whole equals the sum of its parts, so. All right, try number 7. Be careful. Or, I'm sorry, part F. I saw the -6 in my head.
Oh.
What's your answer? Sam, you get to go first this time.
Would you,
Huh?
That should be 1,
You think the answer is 1?
I'm pretty sure.
Okay. Evan, agree, disagree?
Unless there was something wrong.
Disagree, what's the other
There's
answer?
one little bit that's making me question my own math. It's super simplistic, but I'm overthinking it, so come back to me in just literally 1 second.
1/1000. I'm back. You did say literally 1 second.
Yeah, I can't even be
You
mad.
did say literally.
I said literally, so I can't really too upset. I'm going with -9.
I'm gonna go with -9, so I have a 1, whoops. I have a 1, I have a -9, and what did you say?
1.
1. Okay, so, I'm gonna break this apart, and I'm gonna do the integral from 9 to 7 of h of x.
Wait, can I change my answer?
Too late.
No!
So if I go from,
No!
no,
I
if I
want
go
it to
from
be
9 to 7 and
-1.
switch it, what happens to the 4?
Turns negative.
-4. Minus, then I do f of x, and I change the limits, it becomes a
-5.
-5. So the answer is 1.
Hooray.
Yeah.
Now, if
I
that
only
was a plus
changed the
sign,
first one.
you would have been right.
I only changed the first one was the deal. I didn't change both values.
It's okay, we'll do it next time.
Cause I thought it was
Yeah,
only
and
per value.
The question I was going to ask was if you switch the signs first or subtract and then switch the signs, but it's the same.
It's the same answer. You could do 4 minus 5 to give you -1, right? And then switch the signs to make it a positive, yeah. Doesn't matter which way you do.
Yeah, that's what I realized.
Okay,
That's
very good. Do these kind of make sense? These aren't super
Yeah,
complicated,
let me-
don't make them more difficult than what they are. Those of you on camera, don't make them more difficult than what it is. Actually, you're not on camera, I'm on camera, but you're watching. Alright,
Can you
Let's
go
go to
back
the
so I can
example.
get a
What's the
picture of
answer?
the answers?
what's the answer?
Is that 7 to 7?
It is 7 to 7.
Oh, 0.
Because remember, if the limits are the same, why did I write that there?
And you can see why I was a little confused.
Should have been written up there. Must have been in the,
Can we go back to the previous slide so I can actually get a picture of the answers?
you want the answers?
Yeah.
Oh, no. The answer was just 1. There you go.
Perfect. Thank you.
Alright, fantastic. Okay, so example, we did 0. Now it's back to screwed up again. Okay. Okay, now we get to watch the video. Did you guys ever, are you old enough to ever remember David Letterman?
I believe so.
Okay, so David Letterman used to have the Tonight Show right after Johnny Carson, which was followed by Jay Leno, then it was David Letterman, and then eventually it became Jimmy Fallon does the Tonight Show.
Ugh.
So then Letterman would come on at 11:30, and he always did stupid, crazy things. Here's one of the stunts he did. People would write him letters, and for different activities, and this is one of the stupid stunts that he did. This actually has bearing on what we're doing in class today. Okay, so just, it's funny, it's a nice little humorous thing while I go take attendance.
Archimedes once said, "Give me a long enough lever and a place to stand, and I can move the world." We here at Late Night have a similar philosophy. It goes like this: give me an 80-ton hydraulic press, and we can crush anything. Well, that's what we're going to do here in a machine shop somewhere in New Jersey, next to the the TikTok Diner, a festival of brute force.
What can you do to an alarm clock?
Well, that's an excellent question. What do you do to shut off a noisy alarm clock in the morning? Well, here's what I did. I got one of these 80-ton hydraulic presses, put it right next to the bed. When that happens, you just slide it right under there, and before you know it, you're sound asleep again. Works like a charm. Okay, let's have a look here. There you go. Make a nice brooch, wouldn't it?
How about making something flat as a pancake?
I get it. You'd like to see something flat as a pancake. Well, how about pancakes? And, oh, a little syrup, sure. Morning, honey. What's for breakfast?
How about something from the world of sports?
Okay, here we have a little something from the world of sports, the athletic supporter, and of course, the protective cup. Breaking out in a sweat. Oh! That's the sound every football player dreads hearing. Oh! Oh my God, a cracked cup. Oh, well, it's the chess club for Junior from now on. Something striped. Something striped. Good luck to us all. You know what'd be really cool?
A human head.
I'm sorry, we're not going to do a human head. But how about a Mr. Potato Head? It's apparently made out of the same material that the athletic cup was made from.
I'd like to see some kind of contest.
Well, this will be good. Scientists have theorized about this one for years and years. A competition between the baseball, the softball, and of course, the coconut. The ultimate challenge, never before tested, tonight. I remember when I was a kid at home and my mom would do this, and if I was real good, she'd let me lick the hydraulic press at the end of the day.
Why don't you squash a bug?
Squash a bug? Sure. Seems a little juvenile, but why not? Found this one crawling out of Bill Wendell's hair. Fortunately, Bill was nowhere around at the time.
That took me a second to figure out what it was mean.
Ah, come on, do a human head, will you?
Folks, please, I'm sorry I told you no on the human head. All right, this is as close as we're going to come, a canned ham. But seriously, let's knock off that human head stuff, huh? It's a tasty dip in minutes and seconds, and just pennies a serving. Well, there you have it. Another day at a machine shop in New Jersey. And gosh, I hope you enjoy it. You know, I really enjoyed it, but time to say goodbye. So let's think about all the wonderful things we've learned here tonight. And as always, good night. Thank you so much for watching. And drive safely. Yeah.
All right, if you want to go back and watch the old Lettermans, they did the bowling ball, they did all this stuff, and kind of interesting. Okay, so what did the hydraulic press do?
It's crush.
Took whatever it was and comes down and then it smashed it. Did it always go all the way down to the bottom? No, sometimes it stopped, right? It came down until it got to the point where it couldn't go any further, then it stopped. That's what we're doing with average integrals. If I take the integral of 1/2 x squared and I were to put the hydraulic press and squeeze it down, okay, and make it into a rectangle, a straight, here's my x-axis, here's the, it starts at 0, how tall would that be? If I squeeze it all down to right there, the average value would be where it would make a perfect square. And it would be the y value to make a perfect square. Does that make sense? Okay. So the way we find it is, how do you find average? If I have 4 numbers, if I have 17, 13, 12, and 9, the number of goals Sam scored in the last four games. 17 goals in a game?
Totally.
Perfectly. So how would I find the average of goals?
Add them all up, divide them by 4.
Okay, so add them all up. In other words, I add them all up. Okay, that's what I'm doing with the integral. I'm adding everything up. And then what did you say was the second part?
Divide them by the number of numbers.
So I'm going to divide them, but instead of dividing by the number of numbers in this case, I'm simply going to divide by the width of my rectangle. So what would be the width of this rectangle?
3.
So it'd be 0 to 3, and that would tell me then, what's the average? So if I squeezed everything down 3 inches wide or 3 feet wide, whatever it is, it would go up 1.5. Okay. Now they give us the cute little formula, 1 minus b over a. That's simply how wide is it from b to a. So did we already do this one from 0 to 3, 1/2 x squared? We already did that, right? 0 to 3, 1/2. Oh, was it negative?
Yeah.
Is that the same thing? No, it's positive. Dang. Well, let's do it. Do we have to?
No, just put it into a negative.
Say it again?
Just put a negative sign there.
Well, the answer to the last one, negative 1/2, the answer to, let's see if we can figure this out. From 0 to 3 of negative 1/2 x squared dx equaled negative 9 over 2. We already did that one, right?
Mm-hmm.
So what would be the integral from 0 to 3 of positive 1/2 x squared dx?
It would just be positive 9 over.
Positive 9 over 2. Which is going to be about 4.5. Okay. So then if I want to find the average, I would simply come out front.
Where's 4.5 coming from?
9 over 2 is 4.5.
Well, like, why do we need the 4.5?
So then I'm going to do the average, and I'm going to do multiply by 1/3, or you can just say divide by 3. So what is 4/5 divided by 3? Or 4.5, sorry, not 4/5. 4.5 divided by 3. I thought that'd be an easier division. What's 45 divided by 3? What'd you say? 45 divided by 3? 45 divided by 3?
Where's your calculator?
My calculator's charging.
Dude, it's 15, so our answer is 1.5.
15.
4.5 divided by 3, which gives me the answer of 4.
Oh, it's 15. by
Oh,
the way, Mr.
outstanding.
Phillips.
Yeah, you're a little behind, but thank you.
Yeah, you're welcome. You're welcome.
Alright, so let's do one for real, find the average. The only difference is, I'm putting in this thing right here because that's what the hydraulic press is doing.
So quickly, just to follow, we then still write out the equation like it would be, and then we actually put equal and then whatever the answer is, and then from that, where did we get the 1/3 from to do the division?
1 divided by b minus a. A is 0, b is 3, so 1/3 minus 0. And we actually got it from Josie who said, who said the width is 3. So that's where I'm dividing by 3 or multiplying by 1/3, it's the same math.
Okay, yeah, because all of that's the sum and then.
Okay, you ready? Here we go. Find the average value of the function. So it will say, find the average value of the function. Alright, so y equals x minus 1 squared from 0 to 3. Well, since we haven't, as a class yet, discovered how to do the antiderivative of composite functions, which will come in chapter 6 when we do use substitution, okay, I'm going to go ahead and multiply this out. So x minus 1 squared is the same thing as x squared minus 2x plus 1. Okay, multiply that out. And then let's write out my integral. Okay, so the first thing I'm going to do is the integral symbol, which means what, Sam?
You add,
I'm adding something up.
you add all the rectangles up.
And what do you know about the rectangles? You okay?
I'm just really tired.
Yeah, me too.
Because I was at state for the past 3 days.
Okay, so you're adding up a bunch of rectangles that have what property? What do you know about their widths?
They're all the same.
And they're approaching what value?
0.
0. Okay, and then my limits here are, let's switch it up a little bit rather than do 0 to 3. Let's do 0 to 2. So we're gonna go from 0 to 2. Okay. And then what do I put in next?
The height, which is x squared minus 2x.
You answered my next question as well. You
Why
put
are-
in the function, which happens to be the height of the rectangle.
So why are we using x squared minus 2x plus 1 instead of the x minus 1 in the second?
I
Are
haven't
we
taught you how to
simplifying?
take the antiderivative of a composite function yet.
Oh, okay.
A function within a function.
So you just
I just
solved it
multiplied
out.
it out, because we can do the power rule very quickly. Okay, and then of course I have to put in here something, and what does that stand for?
Width.
Width. Alright, so everything's the same. Now I'm gonna do the average value, right? So out here I'm gonna put 1 over what? 2, and you get that from 2 minus 0. Don't always assume it's gonna be the top number, because if I went from -5 to 2, that would be 1 over 7, because it has a width of 7. So make sure you actually subtract. Okay. Alright, antiderivative. What's the antiderivative of x squared?
1/3 x cubed.
1/3 x cubed. Minus, what's the antiderivative of 2x? Be careful.
1x squared.
What'd you say?
1x squared.
And I'm not even gonna put the 1 in there, I'm just gonna put in x squared. Seriously? Okay, plus, what's the antiderivative of 1?
X.
Be like, so it's like x to the 0, so you have to add 1 to it, so it's like x to the first. Right? And then Susan's ugly line, and then from 0 to 2. Now, the way I do these is I just leave this out front, then I'm gonna take care of it at the very end. Okay? So go ahead and plug them in. Do I need to bother plugging in 0? In this case, every term has an x, so I don't need to plug in 0. So I just need to plug in 1/3 times 2 cubed, which is 8, minus 2 squared, which is 4, plus 2. If you want to do it, it would be 0 minus 0 plus 0, if you want to put it in. So 1/3 times 8 is 8/3 minus, what do I change 4 to get a common denominator?
It went back a slide.
Of course. I turn my back on it. Whenever I turn my back, it does bad things. So what I do with 4 to make it with a denominator of 3? 12/3. Plus, change 2 to a denominator of 3? 6/3. Which is going to equal 8 minus 12 is -4, plus 6 is 2, 2/3. And then of course, what do I have to take 2/3 times?
1/2.
Now I bring it down, multiply by 1/2. I should get 1/3.
We've got the 2/3, but how did the 2/3 become 1/3?
Because I multiplied by 1/2, and the 2's canceled. And I got 1/3. So really nothing new today, as far as nothing drastically new. The properties were kind of unique, but not too complicated. And with average, we're simply putting that number out in front. Think of the hydraulic press. Are we good?
We're
So
multiplying
I
it
am
by the
done.
1/2 or dividing it by the 1/2?
Well, you're multiplying by 1/2, which is the same thing as dividing by 2. It is on Schoology, but there's the assignment for 5.2 and 5.3. Please make sure you're working on homework. I had a whole stack turned in the other day. And it'd be nice to get those a little bit at a time as we go. Because grading all at once is, Sam, is kind of a pain.
I submitted.
Caleb, Susan.
I submitted exclusively worksheet.
I actually got a big stack from 3 of you. So
Yeah, I
I
saw
appreciate a little
that.
bit at a time as we can go.
Yeah.
So I don't have to spend so much time at one paper.
I have been a very good student.
You turn things in on time, that's nice.
I'm gonna give it to you all at once.
I can just
Yeah,
see
I
his
just-
eye twitching from
I just see
here.
you walking in May says, Mr. Phillips, here's chapter 1 through 7 homework.
Yes.
Mr. Phillips, here's all of the homework for the entire year.
Yes.
I do need my grades in by tomorrow, otherwise I won't be able to